Hi crew, these are our 4-3 notes on the inverse trig functions and trigonometric equations. We're going to learn the definition of arc sine and arc tangent in these notes. We've previously learned the definition of the arc cosine of x. So let's start with what we already know. We already know that we learned that we could find the sine of x, the cosine of x, the tangent of x, from a point on the terminal side of an angle. So if I had a point UV, then the sine would be V over R, where R was the distance from the origin to that point. Cosine was U over R, and tangent was V over U. So we're going to look at where our trig functions are positive. If I have a point in the first quadrant, so I have some point in the first quadrant, we know that both the x and the y coordinates will be positive, which means that all of our trig functions will be positive. So this A stands for all. If we had a point in the second quadrant, so we have an angle in the second quadrant with a point, its coordinates would be negative for x, positive for y, and since sine is dependent upon the y coordinate, the sine function would be positive, and since cosecant is simply reciprocal of the sine, it would be positive as well. In the third quadrant, where both our coordinates are negative, both cosine and sine would be negative, but the tangent would be positive because it is the quotient of the y and the x coordinates. And of course, the cotangent would also be positive. And then finally, in the fourth quadrant, where the x coordinate is positive and the y coordinate is negative, because cosine depends on x, the cosine will be positive, as will its reciprocal, which is the secant. Right? And so we have this little saying, all students take calculus, just to remember as you go around from quadrant 1 to quadrant 4, that all functions are positive in the first quadrant, then the sine in the second, tangent in the third, cosine in the fourth. Right, now, I don't know if all students really do take calculus, but all of you will be able to because you're going to learn so much this year. All right, let's look at what else we know. We know that if the cosine of theta is positive, then, and the cosine is positive, as all of our functions are in the first quadrant and also in the fourth quadrant, then our angle has to be either a quadrant 1 or a quadrant 4 angle. So let's just kind of look at an example. If I had, say, a 53-degree angle, and there was a point on that terminal side, let's say that that point is 3, 4, then because the cosine depends on the x and the x is positive, the angle whose cosine is x would be this 53-degree angle. So 3. Well, if I were to take the same reference angle, but going into the fourth quadrant, so a negative 53-degree angle, there would be a point symmetric to this point at the same x, 3, but the y would be opposite. And so that's where we get that the arc cosine of x is either the positive of a reference angle or the negative of that reference angle, because that gives us two angles with the same x coordinate. One a first quadrant angle, the other a fourth quadrant angle, plus 360 degrees. And because adding 360 to any of these angles gets us to a coterminal angle, right? We add to this, we come back to this. So we have this definition of arc cosine, which we've already been using to solve trigonometric equations. Now we're going to add 2 more. Okay, what's new to know is this, that if the sine of theta is positive, then theta must either be a quadrant 1 angle or a quadrant 2 angle. So if we think about this, if we take our same reference angle of 53 degrees, and we take a point on that terminal side, which is the point 3, 4, if the sine depends on y, then there's another point here in the second quadrant that would have the coordinates negative 3, 4, and it would give us the same value of the sine, where this reference angle is 53 degrees. So if the sine of theta is positive, then the arc sine of theta will equal the inverse sine of theta, right, which is the angle whose sine is theta. This is our quadrant 1 angle, plus 360 degrees in. Or we want this angle right here, which would be 180 degrees minus 53. So our other possibility is that we have 180 degrees minus the inverse sine of x plus 360. For the tangent, if the tangent of theta is positive, right, tangent is positive when the x and y coordinates are both the same sign. So if we have our 53 degree angle with our point 34, there's a point opposite that with a 53 degree reference angle where the coordinates of my point would be -3, -4, that would give me the same tangent. So I end up with either a quadrant 1 or a quadrant 3 angle. Because the tangent repeats every 180 degrees, if I just take this first angle and add 180 degrees to it, I end up with the second one. If I add 180 to that, I end up with a coterminal angle to my 53 degree angle. And so from there, we end up with this definition that the arc tangent of x is the inverse tangent of x plus 180. So that's kind of the connection to these formulas. Where we end up with is what we have here in this box. We have the definition for arc cosine, which we already know, which is plus or minus inverse cosine plus 360 n if we're in degrees, or plus 2 pi n if we're in radians. For arc sine, we have a little more complicated definition. It is the inverse sine plus 360, or 180 minus the inverse sine plus 360, or if we're in radians, it would be the inverse sine plus 2 pi n, or pi instead of 180 minus the inverse sine plus 2 pi n. For arc tangent, we have simply the inverse tangent plus 180 degrees n, or the inverse tangent plus pi n. So let's see how those formulas work. We're going to find the general solution. Remember, general solution means it's going to have n in it. For theta or x, remember that if we're in theta, we're in degrees. If we're talking about x, we're in radians. And then we're going to find the particular solutions that are in the given domain. So in this first problem, I have theta is the arc sine of 0.4, where theta is somewhere between 0 and 720. So we're going to start and we're going to find, right, we know that if we're finding theta, we're in degrees. That's also indicated because we have degrees in our domain. So we want to solve for theta, and we're going to use our definition. So we have theta by definition is the inverse sine of 0.4 plus, right, we're in degrees, so plus 360 degrees n, or theta, right, could be in the other quadrant, so that would be 180 minus the inverse sine of 0.4 plus 360 degrees n. So looking back, we have just applied this definition, the inverse sine plus 360, or 180 minus the inverse sine plus 360. From here, we're going to turn to our calculator, and we're going to evaluate this inverse sine of 0.4, make sure we're in degrees, and we get that theta is 23.578 degrees plus 360 degrees n, or theta is 180 minus that number, which gives me 156.422 degrees plus 360 degrees n. And this is our general solution for theta. Right? This is general. Now for the particular solutions that fall between 0 and 720, we're going to take our 23.578, that's one of our solutions. And then we're going to take our 156.422. That's a solution. Both of those fall between 0 and 720. Then if we take our 23.578 and we add 360 to that, we end up with 383.578 degrees. And then if we take our 156.422 and we add 360 to that, we get 516.422. If I were to add 360 to either this number or this number, that would take me over my 720. So I stop, and these are my particular solutions. Okay? So there's an example using the definition of arc sine. Let's look at one using the definition of arc tangent. Here I have x. Having x tells me that we're in radians. My domain is from 0 to 4 pi. Keep in mind that pi is about 3.14, so if we multiply that by 4, this is about 12.566 radians. We're going to want that later. So I want to solve for x. I'm going to use my definition of arctan, which is the inverse tangent of -5 plus, right, we're in radians, so it's going to be pi, not 2 pi, not 180, but pi n. Going to our calculator, and again, make sure that you're in radians here. You've got to switch the mode on our calculator. We get -1.373 plus pi n. That is our general solution. I want the particular solutions that fall between 0 and 4 pi. So I'm not going to use this negative number, but if I add pi to that, I end up with 1.768. If I add pi to this number, I end up with 4.910. Add pi again, a little more than 3, and I end up with 8.051. I'm still within this 12.566. Add another pi to that, I've got 11.193. And if I were to add pi to this, it would be bigger than this 12.566. So those are my particular solutions for x. Now we've got arc cosine, right? This is not new. We've done arc cosine before. So we're going to pick up, we've got x, so we know we're in radians. And we know that x will equal, by definition, plus or minus the inverse cosine of -0.3 plus, we're in radians, we're going to add 2 pi n. We take that to our calculator, mode should still be in radians, and we get plus or minus 1.875 plus 2 pi n. These are our general solutions. Now for our particular solutions that fall between -2 and 0.4, I'm going to start with my -1.875. That's pretty close to -2. And then I'm going to take my +1.875. And then I'm going to add 2 pi to this -1.875. I add 2 pi to that. And that gives me 8.15, no, I'm sorry, that gives me 4.408, which is bigger than my 4, so I don't want that. And these are the only solutions that fit between -2 and 4. All right, so that's solving for x using our definitions for the arc sine, arc tangent, and arc cosine. Let's look at a couple problems that are a little more involved than that, and then we'll be done for today. So we want to solve this equation algebraically, and then we're going to verify that solution graphically. So we've got this equation, right? We've got x, so we know we're in radians. no degree symbols, so make sure your calculator is set in radians. We want to solve for x. The first thing we're going to do is we're going to divide both sides by this 10, which gives us the sign of x minus 0.2 equals negative 3/10. Now, I want to get rid of the sign. The way I get rid of the sign is I take the arc sign of both sides. So the arc sign of the sign undoes that sign, and I now have just x minus 0.2 equals my arc sign of negative 0.3. So I'm going to leave that arc sign of negative 0.3, right? 3/10 is 0.3. Okay, so now we have a choice. I think I'm going to start with this definition. No, I think I'm going to add this 0.2 to both sides. So I'm going to add this 0.2 to both sides. So that gives me x equals 0.2 plus the arc sign of negative 0.3. Now, that is x equals 0.2. I have two definitions for arc sign. So I'm going to add one of those definitions, which is the inverse sign of negative 0.3. Let's see, we are in radians, so plus 2 pi n. Or, we're going to now use the other definition. We get x is equal to 0.2 plus 1, not 180, because we're in radians, plus pi minus the inverse sign of negative 0.3 plus 2 pi n. Now we go to our calculator and we plug in this inverse sign of negative 0.3, and we get that x is equal to our 0.2 minus 0.305, that's what our inverse sign of negative 0.3 is, plus 2 pi n. Or we get x is equal to 0.2 plus pi minus our negative 0.305 plus 2 pi n. We can simplify that a little bit, so these two numbers can be combined. Neither one has the n in it, and I get x equals negative 0.105 plus 2 pi n. Or, on this side, we can combine 0.2 pi, and minus the negative would be plus 0.305. So I end up here with x equals, and combining those two, we get 3.646 plus 2 pi n. Those are our general solutions. For our particular solutions between 0 and 4 pi, we would start with our 3.646. Then we would follow what we get by adding 2 pi to this negative number. And that gives us 6.178. And then if we add 2 pi to this number, we get 9.929. And then adding 2 pi to the second number, we get 12.462. Which is as high as we're going to be able to go without getting past our 4 pi, which is our 12.566. So those are our particular solutions. So, to verify by graphing, we would graph y1 equals the left side 10 times the sine of x minus 0.2. and as y2, we would graph y equals -3, and we would set our window so our x-min is at least 0, maybe below, and our x-max is a little bit above 4 pi, and we would use our intersection feature. We'll try to look at that in class. One last example here. We've got 4 times the tangent of theta equals -5, and we want the first 3 positive values of theta, right? We are looking for theta, so we are in degrees here. And I'm going to start by taking this equation and dividing by 4 on both sides. So that gives me the tangent of 2 theta equals -5/4. We're going to take the arctan of both sides. Right, so that undoes my tangent, leaves me 2 theta equals, my definition of arctan is inverse tan of -5/4 plus, we're in degrees, so we'll add 180 degrees n. My next step is I want to divide both sides by 2. Right, that divides out the 2 and leaves me theta. Be very careful with the left side that this division of 2 has to go to both terms, so I end up with 1/2 my inverse tangent of -5/4 plus 1/2 of 180 degrees n. Going to my calculator, I plug in 1/2 of the inverse tangent of -5/4, and I get -25.670 degrees, plus half of 180 is 90, so I get 90 degrees n. That's my general solution. For my particular solutions, I want my first 3 positives, so I'm not going to take this -25, but if I add 90 degrees to that, I get 64.330 degrees. Add 90 to that, and I get 154.330 degrees. Add another 90 to that, and I get 244.330 degrees. And I have my first 3 positive solutions to that equation. So I know these problems take a lot of steps, and the definitions, right, can be multifaceted, but you can do this. I absolutely believe in you. You're a brilliant group of kids, and I'm going to be excited to see how easily you master this. See you tomorrow.